In this video, we're going to start talking about complex numbers and the imaginary unit I. So I comes from the square root of -1. So as you know, as we talk about square roots, we can't take the square root of a negative number and get a real solution. So now we're going to talk about complex and imaginary solutions. So the square root of -1 is I. And if I start off with the square root of -1, and I say that is I, and then I square both sides of those equations, or of that equation, I would have I squared equals, well, we're taking the square root and then we're squaring it, we're undoing that square, or undoing that square root, and that's where I squared is -1. So if we take an imaginary number and multiply it by itself, we actually end up with a real number. So let's practice going back and forth between radical notation and then using the I notation. So I could rewrite the square root of -25 as the square root of -1 times the square root of 25, right? Because we can go back and forth using that product rule of radicals that says I can split them apart and take the square root separately or bring them back together under the same radical. So in this case, I'm splitting apart that negative and the 25. Then I know the square root of -1 is I now, and the square root of +25 is 5. And in general, we will write it with the number first and then the I. Just like with variables like x's, we would write 5x. We're going to do the same thing with imaginary numbers. We'll write 5i. All right. In part B, we have the square root of -3. Now again, I can break this into the square root of -1 times the square root of 3. Square root of 3 is not a perfect square, so I'm going to leave that alone. And then the square root of 1 is just I. Now you might see in some textbooks that they prefer you write that square root first and then the I. I personally prefer the I first so that I know it's not going to accidentally get written underneath that radical. So don't do that. Make sure that it stays out of the radical. And for me personally, I prefer the I first, so there's no confusion at all. It'll be I times the square root of 3. This last one here, it says the negative square root of -50. Okay, these two negatives do not make a positive. You cannot multiply them together. One is outside of the radical, one is underneath the radical. So I still have that negative out front. I can take out the -1 from the 50. And then I have the square root of 50, which can be simplified. So if I factor 50, I'll get 25 times 2 and 5 times 5, which is our perfect square. And then I need to rewrite it all. So I still have the negative, and I'm going to write the numbers first. So the square root of 5 squared is 5. So I'm taking out these 5's from the radical. And then I have the square root of -1, which was I. And what was left under the radical was the 2. So the 5 and the 2 came from the 50. The I came from the square root of -1. And there was already a negative there. And again, this is how I would prefer you write it. But you may see homework or textbooks that prefer you write the real number part first. So that -5 square root of 2. And then the I. Either way would be accepted for me on a test. Alright, now we're going to get into multiplying radicals with negatives, or dividing them. So before you can multiply these, because the square root of -3 is not a real number, and the square root of -7 is not a real number, we have to take out the i's first. You have to rewrite this with the I notation. So I'm going to rewrite it as I square root of 3, right? Take out the negative 1, times I square root of 7. And since this is all multiplication, this is really saying I times that square root of 3 times I times square root of 7. And multiplication is commutative, so I can rewrite this in any order I want. I'm going to do I times I and get I squared. And we learned up here that I squared is equal to negative 1. So anytime I see an I squared, I need to change that to negative 1 because I times I makes a real number, which is negative 1. And then the square root of 3 times the square root of 7 is the square root of 21. Or we can just write this as negative square root 21. Right? So the numbers under the radical can get multiplied together, and I squared becomes negative 1. We're going to do the same thing in part B. We have to rewrite it in the I notation first. So the square root of negative 25, we learned up here, was 5i. Because the square root of that negative is I, square root of 25 is 5. So I get 5i times the square root of negative 1. Well, the square root of negative 1 is I itself. So just times I. And then 5i times I is 5i squared. And I squared is negative 1. So I end up with negative 5. Sometimes you might have the urge to try to multiply these together first. So using that product rule of radicals, you want to bring it together and say, oh, negative 25 times a negative 1 is a positive 25. But the square root of positive 25 is 5. And we ended up with negative 5. Okay, so you can't do that. You must, if you have a square root of a negative number that is not a real number solution or a real number, so you have to convert it to an I first and then simplify. Why don't you go ahead and try examples C and D. So again, rewrite it into I notation first and then simplify what's left. Alright, this first example, I have the square root of 27, which is a real number, times the square root of negative 3, which is going to be an imaginary number. So I can go ahead and simplify the square root of 27, since that's a real number. I'm going to take that and I'm going to multiply 9 times 3 to give me 27, and 9 is 3 times 3. So there's my perfect square that I can take out. So I can rewrite square root of 27 as 3 times the square root of, there's still a 3 underneath the radical. Then I can rewrite the square root of negative 3. I can take out that negative 1. Square root of negative 1 is I. I still have a square root of 3. And as you see here, again, this is all multiplication. 3 times the square root of 3 times I times the square root of 3. I can rearrange this. I'm going to write 3i first, and then multiply those radicals together. Square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. So I end up with 9i. That is one way to approach it, by simplifying the radicals first and then multiplying. The other way would be to just rewrite this one term with the I notation, and then you'd end up with square root of 27 times the square root of 3, which would give you the square root of 81, which square root of 81 is 9 also. So either way, as long as you take out that I first, then you can approach simplifying whichever way makes the most sense to you. Either simplify this radical first, or bring the two remaining after the I is taken out together, and then simplifying. You should end up with the same answer. Alright, on the last one here, part D, I have to take out that I. So square root of -1 is I. And then I could factor the 8. That'll be 4 times 2, and 2 times 2. Here's the perfect square. Square root of 2 squared is 2. And then there's still a 2 underneath the radical that did not have a buddy, divided by 2. And I see right away 2 divided by 2 is 1. And I'm left with just I times the square root of 2. You cannot divide the 8 and the 2 here as is, because the 8's under the radical, the 2 is not. So we pulled out the I, we simplified that radical, and then we could see, oh, here's 2 divided by 2, which gives me 1, and I'm left with I times the square root of 2. So there you go. Anytime now that we see square roots of negative numbers, we know we can take out I.